Great. So we have taken a look at what acids and bases are. And at this point, we've talked about some properties of acids and bases. So acids have a low pH. They turn universal indicator red. They make hydrogen ions. Bases have a high pH. They make hydroxide ions. They turn universal indicator blue. So these are some of the things we've talked about with acids and bases in our maybe readings from last week. And here we go. Okay, now I'm going to scroll down. And today what we're going to look at is what happens when we add acids and bases together. So there's this page here in your OneNote where we're going to collect some data. And what we're going to do is in 5 different wells, we're going to put 5 drops of HCl in these 5 different wells. Then we're going to add some universal indicator. And then 1 drop we're going to leave as is. And to 1 well, we're going to add some water. Other well, we're going to add even more water. And then we're going to do the same thing, but with base. So we're going to add some sodium hydroxide and then add a little bit more sodium hydroxide. And we want to write down our observations. So what color are these solutions? That's what our observations are going to be. So I am going to get this. Okay, so we see a variety of wells here. And notice how I have them labeled so you can tell what's what. So in 5 of these wells, I'm going to put 1, 2, 3, 4, 5 drops of HCl into 5 of these wells. 3, 4, 5. I'm going to get some more. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And then what I'm going to do is I'm going to add a drop of universal indicator to each of these ones. And I'm putting it in acid. So these should all start out red. So we can see, remember, universal indicator is kind of a rainbow scale. The red side of things is acidic. The blue-purple side is basic. And what we're going to do is we're going to see the impact of adding water and the impact of adding sodium hydroxide, which is a base. So first I'm going to, I've got a little beaker of water here. I'm going to try adding a little bit of water. So if I add 1, 2, 3, 4, 5, 6. Notice how I added a bunch of drops of water and nothing really happened. The color is still red. Now let me try adding 15 drops of water. 1, 2, 3, 4. And notice how the color is still basically staying the same. So the pH does not change very much when we are adding water. Now let's try adding a base instead. So I've got this base here. And I'm going to add 1, 2. All right, we'll see if you can kind of see a change happening there. I'm going to try and swirl it up a little bit. Aha, notice how with just adding 10 drops of sodium hydroxide, it turned green. So now my solution is pretty neutral. So now I'm going to try this with 15 drops. 1, 2. And when I add 15 drops, it's turning purple. So we can see that adding a, let's add one more there. Adding water does not have a big impact on our pH here. Adding sodium hydroxide has a much bigger impact on our pH. And that's because when you add sodium hydroxide, which is a base, to our acid, a chemical reaction is going to occur. And that's something we call a neutralization reaction. We just saw in the wells is we saw 2 little mini examples of dilution and then neutralization. So in the wells where we added water, what we were doing is we were diluting the acid, and we saw that diluting was not super effective at changing the pH. It did not change very much. And with the other couple of wells where we added sodium hydroxide, there was a chemical reaction occurring. There's a neutralization reaction. That's what happens when you combine an acid and a base. And so we're going to take a look at one more demonstration of this. We're going to take a look at the volume of water needed to change the pH of a sample versus the volume of sodium hydroxide. So we're looking at this slide right here. And what we're going to do is we're going to take a small sample of HCl, so let's say 6 drops of HCl. We're going to add some universal indicator, and then we're going to add some water and see how much water it takes to neutralize that sample. And then we're going to do the same thing, but add sodium hydroxide instead. All right, so here I have a beaker that's already got some universal indicator in it. And I'm going to start out by adding 6 drops of HCl. Here we go. We swirl that around. It turns bright red. So this is very acidic, okay? And what we're going to try and do is we're going to try and add some water slowly and see how much water it takes to change the pH here. So we saw just adding like a few drops of water doesn't change the pH. Okay, so far now I've had about 100 mils, still pretty red. Now I'm up here about 150, solution still red. I'm here at about 200, the solution's still red. And oh, there we go. We just barely, once we hit maybe like 250, it finally started to change color. And it's still, not even quite neutral. It's yellow. So we see with dilution, it's going to take a lot of water to change the pH here. And that's because the pH is a logarithmic value. So it takes a 10-fold change in concentration to change the pH by 1 unit. So it took a lot of water just to even kind of begin to start neutralizing this acid. Okay, so now what we're going to do is we're going to do the same experiment. So I started again with about 6 drops of HCl, and I added a bunch of indicator. And this time, instead of adding water, I'm going to try adding some sodium hydroxide. So I'm going to add sodium hydroxide, 1, 2, 3, 4. And I'm going to swirl along the way. Let's see, 5, 6, 7, 8, 10. And I figure out how many drops of sodium hydroxide it takes to neutralize it. So I've added 10 drops so far. This is 13 drops. Oh, and look at that, at 13 drops, there we go, the pH turned to neutral. So the pH changes much more rapidly when you're adding sodium hydroxide than adding water. That's because you have this chemical reaction occurring. And now we have neutralized our sample.